This is problem number 1 from assessment number 3. In this problem it says the table lists data that is exactly linear. Find the equation of the corresponding line and use it to predict other values. So they tell you in the problem that this data is exactly linear. Now because they say exactly linear, we need to assume that we can use any of these 2 points to find the slope because it's exactly linear. If they wouldn't have said that, a good method for finding the slope would maybe to use the endpoints of your data, like from this spot to this spot to kind of find the slope. So I'm just going to use that as a good method for finding slope in general. But we know because it's exactly linear that the slope between each of these points is the same. So it doesn't matter which set of 2 points I use. So I'm going to use the first point, which is -3, comma, -8.7. And I'm going to use the second, or the end point, which is 1, comma, -1.5 to find my slope. So m equals rise over run, which is y2 minus y1 over x2 minus x1. So I'm going to label this x1, y1, x2, y2, and then I'm going to plug those in. So that's -1.5 minus -8.7 all over 1 minus -3. So that's going to give you -1.5 minus -8.7 gives you 7.2. Plug that in the calculator. And 1 minus -3 will give you 7.2 over 4, which when you divide this, if you look what they want, they say type an integer or decimal rounded to the nearest tenth. So they're asking you for a decimal here. We'll divide it. We end up with 1.8. So our slope is 1.8 for our line. So we're going to have y equals 1.8 x plus b. Now we got to find b. So we can use any of these coordinates and plug one coordinate into x and y and find b. Or we can notice that this coordinate is the y-intercept because x is 0. Anytime x is 0, you're obviously on the y-axis, which would mean that you must be the y-intercept. So -3.3 is that b value. So we can replace b with -3.3 and say y equals 1.8 x minus 3.3. And maybe I could even circle this and say that this is the y-intercept. All right, and now that I have my equation, they want us to do some predictions. So they want to predict y when x is -2.3. So if I want to do this part A piece and predict this, I'm going to plug -2.3 in. So I'm going to say x equals -2.3, and then I'm going to say y equals 1.8, -2.3 goes in for x, minus 3.3. So y is going to equal, we plug that in the calculator, and I'll get -2.3 times 1.8, and then subtract the 3.3, we get -7.44. So they want us to round this to the nearest tenth, so we're going to say -7.4 is the y value. Now, if we look at this, they're asking us for an x value that's between -3 and -2, right? It's between these two x values here. That means my y value needs to be between these two pieces of data. Well, -7.4 is right in the middle between those two. So that makes sense for a value. Now it says predicting y for this value of x is an example of which of the following. So this is just some definition stuff. If my data point that I was checking, like -2.3, if that data point is between other data points that are already defined in your table, Then you have what's called interpolation. So that's interpolation. If it's outside of the data, then you have what's called extrapolation. So if it were like, say in the next problem, they're asking us predict y when x is 5.4. Well, we don't have 5.4 on this chart, so the next one is actually going to be extrapolation. So let's do that when y equals 5.4. So this is like a prediction. This is in between our data points, so we have some data there. This would be like a prediction based on data, a different data set. So we're just making a prediction for a value that's larger. So y equals 1.8. We plug in the, this should say x equals 5.4, right? X equals 5.4. So y equals 1.8. We plug 5.4 in here, minus 3.3. So the y value is going to equal, plug 5.4 times 1.8. That's 9.72, and we subtract 3.3. That's 6.4. They want it rounded. It's 6.42, but they want it rounded. So 6.4 is the y value for when x is 5.4.